So let me start presenting now. Okay. So I hope my screen is visible to everybody.
Yes, sir.
All right. So, today we are going to see the concept of isoparametric element, subparametric element, and the superparametric element. This is one of the common question which is asked in the end semester examination. So I want everybody to pay attention as far as these elements are concerned. Okay. Now, till now, we have seen a simple bar element, isn't it? And we have seen the bar element can have, let us say, two nodes. Okay, so let us say this is one bar element and this is, say, another bar element. For example, this element has got two nodes. Okay, and the other element, it has got, let us say, three nodes. Okay, so one node is over here, another node is over here, and the third node is somewhere over here. Okay, so now since there are three and two nodes over here, you will have two shape functions. Okay, so here the n1 value will be, we have seen in the previous class, so n1 value over here, expression is something like 1 minus xi by 2, and your n2 value will be something like 1 plus xi by 2. So like I said earlier, this is node 1 and this is node 2. But for this element, we have three nodes. So you will have three n1, n2, and n3, that is three shape functions. And if you remember, so your n1 value is nothing but minus of xi into 1 minus xi divided by 2. Okay, your n2 value is nothing but half of something like 1 minus xi square. Okay, and your n3 value, okay, is something like xi into 1 plus xi divided by 2. Okay, let me check. I think this is not 1 minus, just let me check. I think I have wrongly mentioned n2. Okay, please make the correction. This n2 is not half. Okay, please make the corrections over here. Okay, this is not half, this is 1 minus xi square only. Okay, so everybody please make correction over here. Okay, even if you go for this, you will get only 1 minus xi square. Okay, 2 is going to get cancelled. Okay, so एक मिनट, मुझे चेक करने दो. आई थिंक थोड़ा सा कंफ्यूजन है. ठीक है, I'll clarify this afterwards. So for the time being, you just continue with this one, that is 1 plus xi by 2, half of 1 minus xi square, and 1 plus sorry, xi into 1 plus xi. ये 2 आना चाहिए कि नहीं आना चाहिए? 2 नहीं आना चाहिए ना, मुझे थोड़ा कंफ्यूजन है बिकॉज आई एम हैविंग
सर -1 ही आता है डिनोमिनेटर में डेरिवेशन के हिसाब से जो कल डिराइव किया.
ओके, ठीक है, तो कल के इसमें थोड़ा सा चेंजेस कर लो. ठीक है, ठीक है, तो ये वाला 2 नहीं आना चाहिए. बराबर?
यस सर,
है ना. एंड हियर आल्सो आई थिंक this should be 1 minus xi square. Okay, और बाकी का I think suppose everything is okay, isn't it? Okay, anyway, so here you just remember that this is 1 plus xi square. Okay, so now what I'm trying to say over here is we have a function. Okay, so generally what we do, if you remember, we have assumed the function as x equals to a1 plus a2 into xi. So if you use this, you are going to get the same n1 and n2. And if you use something like u equals to a1 plus a2 times q, then also you are going to get same n1 and n2. As far as this part is concerned, we have used x equals to a1 plus a2 times xi plus a3 times xi square. Okay, and if you solve this, you are going to get n1, n2, n3 values like this. And if you assume the value of u as something like a1 plus a2 times q, okay, plus a3 times q square, then also you are going to get something like this. Okay, so in general we have now two displacement polynomial and the polynomial which is used to define the geometry. Okay, now here you need to understand this particular thing. Okay, so this is nothing but your geometry. Okay, and this is nothing but your displacement. Okay, so now two things, one is geometry and one is displacement. Now the order of the polynomial which is used to define the geometry and the order of the polynomial which is used to define the displacement, if both orders are same, in that particular case the element is called as the isoparametric element. Okay, so I'll repeat one more time that if the order of the polynomial which is used to define the geometry is same as the order of the polynomial which is used to define the displacement, is called as an isoparametric element. Okay, so if you talk about just a 2D two noded element, let us say this particular element. Okay, so for this particular element the order of the displacement polynomial to define the geometry. Okay, तो यहाँ पर order कितना है तुम्हारा, one order है, because it is something like a1 equals to a1 plus a2 times xi. So यहाँ पर xi का power कितना है, 1. So the displacement which is used, or the polynomial function which is used to define the geometry, its order is 1. And if you talk about the displacement, its order is also 1, because here you see a1 plus a2 times we have now q. Okay, so q to the power 1. So here this both the order of the polynomial is same, therefore this will be called as isoparametric element. Okay, if you consider the three noded bar element. Okay, so in the three noded bar element, geometry and displacement. Okay, now here if you see the order of the polynomial which is used to define the geometry, तो geometry में define करने के लिए क्या किया, we have used a1 plus a2 times xi to the power 1, okay, plus a3 times xi to the power 2. So the order over here is 2. Similarly, if you see the deformation polynomial, so this is a1 plus a2 times q plus a3 times q to the power 2. So this is also 2. So since the order of the polynomial which is used to define the geometry as well as the order of the polynomial which is used to define the displacement, since both are same, therefore this particular element is called as again isoparametric element. ठीक है? Okay, so this is isoparametric element, right? So now if I write over here, so what you are going to get is something like this, that is the order of polynomial used to define displacement or geometry is same. Okay, so this is exactly same to define the displacement. Okay, so in this particular case it is called as an isoparametric element. Okay, I hope this is clear to everybody. Is it okay?
Yes, sir.
Okay, so once this is known, what you can do is you can go for the derivation of stiffness matrix. Okay, and the derivation of stiffness matrix is very simple. First of all, you have to calculate the strain. Strain is nothing but du by dx, which can be written as del u by del xi and del xi by del x. Okay, so now here you have to use du by dxi. Okay, so for this purpose you will be using the expression which is used for displacement. Okay, so displacement का equation क्या था? So displacement will be something like n1 q1 plus n2 q2. Okay, if you are using a two noded bar element like this. Okay, If you are using a 3-noded bar element, this will be N1 Q1 plus N2 Q2, okay, plus you will be having N3 and Q3 if you are using a 3-noded bar element, okay. Now here we have to use a dx by dz, okay, because you have a expression of x in terms of what, a1 plus a2 times xi, or maybe if it is 3-noded bar element, so x can be written as a1 plus a2 times xi, okay, plus a3 times xi square. So as a result of this, what you are going to get, x equals to n1 x1 plus n2 x2 in case of 2-noded bar element. In case of 3-noded bar element, so n x will be something like n1 x1 plus n2 x2 plus n3 x3, okay. So we have now depending on whether you are using 2-noded bar element or 3-noded bar element, we have to choose the appropriate equation, and once this is known, you have to get the value of this strain, that is epsilon x. So epsilon x now in general it can be written as, this is nothing but your V matrix multiplied by you have your delta matrix, okay. So we have already seen this strain displacement matrix for 2-noded bar element, as well as in the yesterday's class we have seen this for 3-noded bar element, okay. So I'm not going to repeat this, okay. So I hope this is clear to everybody. Are there any queries? Yes, students, are there any queries? Shall I move ahead? Shall I proceed further? Anyone?
Yes, sir.
Okay. So now let us talk about now a different type of element. Okay. So we have seen the isoparametric element. Let us try and understand what is subparametric element. Okay. So this is sub. Okay. So now in short, this subparametric element, what are these subparametric element? Okay. So in the subparametric element, the order which is used to define the geometry, okay, so the order of the polynomial which is used to define the geometry is less than the order of the polynomial which is used to define the displacement, okay. So when this is the case, in that particular case, the element is called as a subparametric element, okay. So now let me explain you with the help of example. Now here you see the orders will be different, so we cannot use simple 2-noded bar element, okay. We have to go for at least minimum 3-noded bar element, okay. So for example, I have a 3-noded bar element like this, okay. So this is my 3-noded bar element, and I have this as node 1, and I have this as node 3, and at the center I have node 2, okay. So now as per the definition, the order of the polynomial which is used to define the geometry is less. So what I am going to do over here, so I am going to have x equals to a1 plus a2 times x. So this is a2 times xi, not x, this is a2 times xi. So here the order is just one order, okay. Order is just one, but the polynomial which is used to define the displacement, that is u, will be something like a1 plus a2 times q plus a3 times q square. So here if you see, the order will be 2. So here the order of the polynomial which is used to define the geometry is less than the order of the polynomial which is used to define the displacement is there. That's why this is called as a subparametric element, okay. So now if you use this, so in that case what you are going to get, x will be now n1 x1 plus n2 and x2. So now in this case what is going to happen, we are using only second order, okay, only the first order. That means we are not using the center element to define the geometry. We are using only the element or the nodes which are there at the ends, okay, to define the geometry. But to define the displacement, what you are going to get, you are basically using all 3 nodes, okay. So node 1, node 2 and node 3 all are used. Therefore what you are going to get over here, this will be n1 q1 plus n2 q2 plus n3 and q3, Okay, but now you can see the difference, because here only 2 nodes are used and here only 3 nodes are used. And when we have used these 3 nodes, so what we have something like over here, that is this x2. So x2 will not be x2, x2 will be your x3, because the x2 is basically the node which is there at the other end, but in this particular case this is nothing but the last node. Therefore this has to be x3 value. Okay, so with this, now if you want to derive the stiffness matrix, so in order to calculate the stiffness matrix, first of all you need to calculate the strain. So strain is nothing but du by dx, and it can be written as del u by del xi. Okay, del u by del xi multiplied by del xi by del x. Okay, so now let us focus on del u by del xi. So here you see we have to use this u, isn't it? So as a result of this, what you are going to get, this is something like d by d xi of n1. Okay, then we have d by d xi of n2, del by del xi of n3. Okay, multiplied by, you will be having q1, q2 and q3. Okay, so we already know the value of n1, n2, n3 when we are using 3 nodes. Okay, so here the value of n1 will be something like minus of xi, 1 minus xi divided by 2. The value of n2 will be something like 1 minus xi square, and the value of n3 will be it is something like xi into 1 plus xi by 2. Okay, so if you go for the derivation of this, so you are going to get some values. Okay, and these values will be of order 3 by 3. Okay, so here let me write some value. So this is del u by del xi will be something like, this is, let us say, x, x and x. Okay, multiplied by, you have q1, q2 and q3. Okay, I hope this is understood to everybody. ठीक है बेटा, आया समझ में? Yes student, is it okay?
Yes sir.
ठीक है. Now when I talk about, so this part is over now. Okay, so this part is now over. Now let us focus on this part, del xi by del x. Okay, now as such we don't have a value of xi which is depending on x. Okay, we don't have this, but we have the value of x which is depending on the value of xi, and this we have already seen that the value of x can be written as x is nothing but a1 plus a2 times xi. Okay, why I am writing this a1 plus a2 times xi? Because I have used a polynomial which is of only first order to define the geometry. So as a result of this, what we can get is something like x is equal to n1 x1 plus n2 x2. Okay, what we are interested in is d, or rather del xi by del x. Okay, because this is required over here. Okay, so del xi by del x, we cannot go for del xi by del x, but definitely we can go for del x by del xi. Okay, so del x by del xi can be written as del by del xi of n1. Okay, into, we can have something like x1 plus del by del xi of n2 into, we can have x2. Okay, where here now in this case the value of n1 and n2, they are different because they are using only 2 nodes. So if you use 2 nodes, what is going to happen is a n1 value will be 1 minus xi by 2, and this will be 1 plus xi by 2. Okay, so as a result of this, what you will have is a matrix which is having 2 coordinates. Okay, I hope this is clear to everybody. Yes student, is it okay?
Yes sir.
Yes student, is it okay? समझ में आया? अरे बोलो भाई, कुछ तो बोलो, आ रहा है कि नहीं आ रहा है? पक्का बेटा, इसका थियरी क्वेश्चन आता है तो तुमको इसको एक्सप्लेन करना है अलॉन्ग विद द डेरिवेशन पार्ट. Okay.
Yes, sir.
Okay. Okay. So here in this particular case, this dx by dxi is also called as your J matrix, isn't it? So your J is nothing but something like this. So you can have values. Okay. So 1 minus xi by 2 और उसका अगर तुम डेरिवेटिव लोगे तो वो क्या आएगा तुम्हारा -1. Okay. So this will be -1 into x1 and this will be +1 into x2. So in short, this is nothing but x2 minus x1. So x2 minus x1 is nothing but your L. Okay. So your determinant of J comes out to be L. Okay. So now what you can have, you can just simply write this matrix, that is epsilon. Okay. So your epsilon, that is strain matrix. Okay. So strain matrix is nothing but you have du by dxi. So du by dxi we have already calculated something like this. So your du by dxi is this. You have some term multiplied by, you have q1, q2 and q3, and here you are having dxi by dx, and just now we have seen dxi by dx is nothing but your L. So finally you will have a matrix that is epsilon. So this is, let us say, epsilon x. So epsilon x is nothing but L into some values which are coming from the derivation multiplied by, this will be q1, q2 and q3. Okay. So this much portion is called as B matrix. Okay. So B matrix is what? Strain displacement matrix. So on this side we have strain and on this side we have displacement. Okay. So once this strain displacement matrix is done, so what you can get the K elemental. So this is integration over the volume, then B transpose into D into B over dV, and we can have this as -1 to +1. So this will be B transpose, your D value will be nothing but your E, this will be B, and this can be written as determinant of J into A into, we can have something like dxi. Okay. So all what we can do is you can go for this entire derivation, and as a result of this you are going to get a stiffness matrix of size 3 by 3. Okay. Remember, in this particular case the stiffness matrix will be of size 3 by 3 only. Why? Because your B matrix is nothing but like this. So 1 row and 3 column. This is 3 row and 1 column. Okay. So ultimately it is going to give the 3 by 3 matrix. Okay. So always remember, for this particular case, which is the subparametric element, your stiffness matrix will be always of size 3 by 3. Okay. As far as your isoparametric elements are concerned, where the order of the polynomial which is used to define the geometry is same as the order of the polynomial which is used to define the displacement. Okay. So in this particular case, the stiffness matrix will be of size 2 by 2 if 2 nodes are used, and if we are using 3 nodes, in that particular case the stiffness matrix will be of size 3 by 3. Okay. I hope this is clear to everybody. Shall I continue? Yes, student, shall I continue? कुछ डाउट है?
Yes, sir.
डाउट है राधिका?
No, sir.
Okay then. So let us continue now, and this time we will see the super parametric element. Okay. So let us see what is the difference between this super parametric element and the other one. Okay. So let me draw a straight line over here. Okay. So now let us say this is a super parametric element. Okay. So now in the super parametric element, we have the order of the polynomial which is used to define the geometry. Okay. So in this particular case, this order is greater than the order of the polynomial which is used to define the displacement. Okay. So in this particular case, the element is called as the super parametric element. Okay. I hope this is clear to everybody. Okay. Exactly the reverse of subparametric element. Okay. So now let us quickly go through the derivation part now. Okay. So again, since 2 orders are different, so at least we have to take a 3-noded bar element. Okay, so it is having 3 nodes, so this will be node 1, this will be node 2, and this will be node 3. Okay, so now the order of the polynomial which is used to define the geometry, it should be higher. So in that case, I'll be using x equals to something like a1 plus a2 times x plus a3 times x square. So this is of second order. Okay, and the order of the displacement or the polynomial which is used to define the displacement will be smaller. So this will be a2 times q. So this is of first order. Okay, so now if you use this, so what you can get, x can be written as n1 x1 plus n2 x2 plus n3 x3. Okay, because this is of second order, so you will be getting 3 nodes. So basically what you are doing, you are using all 3 nodes to define the geometry. Okay, so here all 3 nodes are used to define the geometry, but to define the displacement you are using only 2 nodes. So as a result of this, what you are going to get, u will be something like n1 q1 plus n2 q2. Okay, I am not writing q2, I am writing q3, because the second node, if you ignore the first node for defining the geometry, the third node over here will become your second node. Okay, so this will be n1 q1 and this will be n3 and q3. Now because of these assumptions, the entire thing is going to get changed, because when you want to derive the stiffness matrix, first of all you need to write the epsilon x. Epsilon x is nothing but du by dx, and du by dx can be written as del u by del xi multiplied by del xi by del x. Okay, so for the timing, if you focus on this, so this is del u by del xi, so this will be nothing but del by del xi of, you will have n1 into, this will be del by del xi of n2. Okay, that's it, because the displacement are having only 2 components, so this will be q1 and q3 only. Okay, so in this particular case, the value of n1 and n2, this will be 1 minus xi upon 2, this will be 1 plus xi upon 2. Okay, but when you talk about d xi by dx, okay, so I'm talking about this one now. Okay, d xi by dx, we cannot go for d xi by dx. Okay, so d xi by dx, we definitely not do this derivation, but we can go for d del x by del xi. This is nothing but your J matrix, isn't it? So this is nothing but something like d by d xi. Now here it will be n1, okay, and then x1, because here you see this is the equation which we have obtained. Okay, so we can write the same terms over here. So we can have del by del xi of n2 into x2, then plus we have del by del xi of n3 into x3. Okay, so if you go for its derivation, you have to use n1, n2 and n3 values of 3 nodes. Okay, so the n1 value is nothing but minus of xi into 1 minus xi divided by 2. This will be 1 minus xi square, and this will be xi 1 plus xi upon 2. Okay, so use these values and you can get the Jacobian matrix. Okay, that is the J matrix. So you already know the coordinates of x1, x2 and x3. So your J matrix will be of size 1 by 1 only. Okay, so it will be 1 by 1. But if you talk about the strain now, okay, so your strain is epsilon x. So this value now it will become, so del u by dx. Okay, so if you rewrite this particular term, so this will be x and this will be x multiplied by q1 and q3. Okay, so the same term I can write over here. So epsilon x can be now written as something like 1 and 2 multiplied by, you have q1 and q2 multiplied by J matrix. Okay, and this is nothing but your J matrix. So for this particular case, I think your J matrix comes out to be 2L. Okay, I in the previous class probably I might have calculated over here, that is J matrix comes out to be 2L. Let me check. No, in last class we have not calculated. I'm sure it will come something like around 12. Okay, so this is nothing but your epsilon x. So epsilon x now is nothing but J matrix. Okay, multiplied by, you have two elements over here, and we have q1 and q2. So this particular thing is called as your B matrix. Okay, so this is epsilon x, and here you have q1 and q2. So basically what I'm trying to say over here is your B matrix will be having one row and two columns. So if you go for the derivation of the K, okay, so K is integration over the volume. This will be B transpose into D into B over dV. So the same expression now can be written from -1 to +1. Your B transpose will be having only two components. Your D is nothing but your E. This will be 1 and 2, and dV can be written as A into a determinant of J, and this can be dz. Okay, so as a result of this, you will be getting a K of size 2 by 2. Okay, so remember, when you are using a super parametric element, so super parametric element, whenever you are using, you will be getting a stiffness matrix of size 2 by 2, even if you are using 3 nodes, because the order of the polynomial which you have used to define the displacement is only one order, that is of order 1. So it will be having only it will be considering only 2 nodes for the displacement. Okay, but as far as geometry is concerned, we are using the all 3 nodes. Okay, so is it okay with everybody? Have you understood this? The concept of superparametric, subparametric and isoparametric element. Understood this? Yes, is it okay?
Yes, sir.
Okay.
Yes, sir.
So now where these elements are used. Okay, so isoparametric element you can use anywhere. Okay, so let me write down over here. Okay, so this isoparametric element, let me write it down because my handwriting is very poor. So I can write down over here. So this is okay. So this isoparametric element, yes. So here in the case of isoparametric element, the x and u, they are same. Okay, so the order is basically same. You can use this anywhere. Okay, but here you will be getting the K of size 3 by 3. Okay, so if you want to use let us say super parametric element. Okay, so let me write down. So here we have used super parametric element, or rather let me go with let us say subparametric element. Okay, so in case of this subparametric element, the order of x is smaller than the order of u. Okay, so here you can see in the subparametric element, okay, so the order of geometry is smaller and the order of displacement is larger. Okay, so here whenever you are having a problem where the displacement is important, okay, so the displacement, okay, so displacement is quite varying. Okay, so in this particular case you can use the subparametric element, and in this subparametric element the stiffness matrix will be also of size 3 by 3. Okay, now if you want to use say super parametric element, okay, so let me write down over here. Okay, so whenever you are using a super parametric element, so super parametric element means what? The order of the x is greater than the order of the u. Here the prime importance is given on the geometry. Okay, so in this particular case the K will be of size 2 by 2. Okay, so for example you have a very complex geometry. Okay, so we are having some very complex geometry. So if you are using this super parametric element, this will be always better, because the complexity of the problem will be taken care by the super parametric element. Okay, but in this particular case the stiffness matrix will be of lower order, so that will be better because your calculations are going to get reduced, but the complexity of the geometry will be taken care by the super parametric element. In case of sub parametric element, if you want to have more focus and more accurate results as far as displacement is concerned, in that particular case you can have a sub parametric element. Okay, so for example, your geometry is very simple. Let us say you have a simple rectangular object. Okay, so here geometry is very simple, but you want to have a detailed variation of the results. Okay, so in that particular case, for simple geometry you can use sub parametric element, but your deformation will be having a greater importance and your stiffness matrix will be of order very large. Okay, as far as isoparametric is concerned, you can use anywhere. You can have the isoparametric element for any kind of problem, but in this particular case the order of the polynomial for geometry as well as for the displacement, it is exactly same. So your stiffness matrix is not going to make much difference. It will be also of size 3 by 3, and most of the softwares now they are using only the isoparametric element. Okay, so they are having the equal importance to the deformation and the displacement is concerned. Okay, so I hope everybody has understood this. किसी को कुछ doubt है? Yes, students, is there any query? Okay.
No, sir.
Okay then. So we will continue in the next class, and Monica, please stop the recording, and everybody please leave the meet. If you have any queries, then please remain in the class. Otherwise, you can leave the meet. Okay. Yes, Monica, please stop the recording.